Oh, hi. Yeah, another day, another hour and a half of futzing around. So let's get right to it. We're making an NES into a computer. We have to get shit ready for VCF Midwest, which is the weekend after next. So I have some days to get this done. But doing a little bit every day, which is more than I could say for my last VCF project. So that's good. Last time we made a lot of really good progress, in my opinion. And I'm going to hopefully press on with that today and make some more really good progress. So let me just go straight to the... should we do overhead? Should we do... Yeah, why not? We don't get to use overhead enough. So what we've got right here, if you haven't tuned in, is a matrix, a keyboard matrix, a matrix scanned set of keyboard buttons that was ripped out of an old computer that I broke a bajillion years ago. That has its matrix wires hooked up to a whole breadboard situation here, which has a Raspberry Pi Pico right here, and that is only in there to provide some easy, clean clock signals to the rest of the circuitry. But what I've actually got going on here that's doing the bulk of things, and that this keyboard is actually plugged into right now, is you can kind of see this little black chip right there, and this little black chip right there. Those are GALs, which are very simple programmable logic, and I have made one of them into a chip that will read in a row of keys from the keyboard matrix and allow us to shift them out into the serial input of the NES controller. And then I have made this GAL, which is basically just a counter, but it has a count enable input on it so that it only counts when the NES's latch signal is high. So that latch signal is going to be used to basically say go to the next row, and also resets and loads the shift register is the idea. So right now the counter chip, and I should say, hey, we got some regulars in here. We got Wereworm and Dirt Piper. Hello to you both. So you all know what's going on. I was going to use a 74-138, I think. Yeah, let's see. That's enough of overhead. We can go here. A 74-138, it's these guys down there, which is a decoder. And I was thinking that'd be great because they are active low, and I was thinking, no, maybe I want my active matrix line to be low, because usually you pull things to ground sometimes with buttons. I don't know what my logic was. Do I ever have logic? No. So I realized, no, that's not going to work. We really do, because if all of the lines are high all the time except for the one that you're currently scanning, then you're just going to have that flow all over the place. In fact, let me reprove that to myself. Control Shift, there we go. Yeah, let's look at the keyboard matrix. And also, hello to Lawless. Where says, we're here for the gals. We sure are, we sure are. Whether we're into ladies, we're here for gals. Okay, yes, so this. Let's just take another screenshot of this really quick. And... oh my god, where's print screen on this weird keyboard? Of course I don't have a paint up. Paint! There we are. Now I can screw this up to my heart's content. So let's say all of these columns have 5 volts on them, and well, let's just say let's show those 5 volts with green. Right. So all of these except for, let's say this one is not. That's the one that is currently selected, so it would be ground. Dead. It would be grounded. And then blah-de-blah-de-blah. The rest of these are all plus 5 volts. Right. So, you know, if we had 5-volt pull-ups over on this side, which is kind of what it looks like this pin internally has pull-ups because that's what we were seeing before, then these would also all be 5, except, I mean, yeah, like 5, 5. These would just be floating at 5, not pulled to 5, just floating at 5. But let's say, so of course these are not connected. Only when a button is pressed is it connected. So let's say you pressed the O button, that would attach this grounded column to this, and that would pull this to ground because it's attached. But then, let's say you press the 9 key. Now you are attaching this to 5 volts, so you have just shorted 5 volts to ground. Basically, just by going... Oh, I did something very weird. My other monitor is going insane. Apparently, I opened Paint Help. Excellent. Anyway, so basically you'd have 5 volts coming down around here, then through the 9 switch, flowing through this column wire, and then touching ground directly through here. So that would be not great. So let me make sure the opposite logic works, and that I don't need any extra like diodes or anything. Because one of the problems is I don't have high-speed diodes right now. I do have, like, I have some like diodes for rectification in this little drug baggie, but those are the only diodes I have, which might do fine if I really need a diode. But let's work through this first. So then on the flip side, so that's what would happen if I used one of those 74-138s, which is what I have on hand, and yeah, but because it uses active low logic, so all of the pins that are not the active pin would be 5 volts. So let's look at this the other way around. If I make my own a third gal that just works as a decoder, then only one line would be at 5 volts, and then I guess I would want to put pull downs on here, pull them down to ground. That's fine. And then, like, when you press, let's say over here, you press the L key, that causes that 5 volts to be connected to here, and blah blah blah, it goes in there. That one gets, it overrides the pull down, the resistor pulling down to ground, and this becomes 1, and the others are still pulled down to 0. And then if we press any other key on this column, yeah, it'll still go to ground. So I think you really need to put a diode on those, right? Because that's fine. Basically, we always want current flowing out from here. So if we put, a diode on each of these pointing this way. Yeah, sure. Anyway, a diode pointing that way, it would mean that current can only ever flow out of the chip and this way, and can't flow back up here. It would just not do anything. So I think that's okay. Now, can I use diodes in the other case where I just use the existing counter chip I have? Does that work? Because if these are, this is something I was trying to work out in my head the other day, and like my head was just couldn't do it, because I can't do much in my head. Again, I always go back to the ADHD thing. It's probably getting annoying, but I think that's a thing with ADHD. Like, you're really bad at, well, I guess you're bad at holding multiple ideas in your head at the same time. So that's pretty much what ADHD is. Yeah, Werewolf said, oh, Lola said, a little short, never killed anyone. Never killed anyone, but it will, it'll fry your chips pretty fast when they start overheating from, infinite current. And Werewolf says, high-speed diodes, how fast are you going to type? Not very. Those diodes are probably fine. And it's not about the typing, it's about, we're doing all this matrix switching. But it's probably going to be slow enough that it does not matter. Yes, Dirt Piper says, spotty working memory, that and executive dysfunction. The executive dysfunction, woo! That's why I do this stream. Get in the habit of just sitting down at 5:30 and putting in an hour. And only by making it a habit can I accomplish this work. Yes, so Anyway, F it. I need to get this done, so forget even trying to figure out if diodes and the other thing will work. Let's just do another gal, because doing a decoder should be real flippin' easy. Because that is literally one row of a... I can never remember... Is it sum of products or product of sums? A product is an OR. A product is things ORed together, right? Yes. Yes? And, wait, no. Sum. A sum is things ORed together. And a product is things ANDed together. Yeah? Maybe? I don't know. I didn't go to school. But this is not the right window for this. Let's save this as a new thing. Let's call this decoder.pld. And you'd think, can't you just do this in one chip? Why doesn't your... hello, search. Why doesn't your counter chip just, instead of counting by a binary value, do the decoded output? And it's because with these gals, I was kind of saying this last time, but it has a lot of maybe non-obvious implications to things. The flip-flops that are in these things, which there is 1 per output pin, and we have 8 available output pins on the chip, their output is directly connected to the output pin, so you can feed them back into the rest of the logic in there, but you can't, like, have subsequent logic after the flip-flops, and you need the subsequent logic to transform the 3-bit number into a selected line. So in this case, we will need 2 paths to do that. If you were wondering, that's why. But yeah, so let's rename this, because I didn't with the last one, and then it had a really weird, I couldn't figure out where the file was. So let's just call this decoder. And the part number is also going to be decoder. Whatever. Inputs are literally just going to be... We won't even have a clock on this, which is fun. This should be the... Because we're only using this for logic. So that's interesting. And in that case, I think you can use the clock pin as a logical input, but I don't care to... Again, I'm just going to do this as quick and easy as possible, do something that works. As relatively quick and easy as possible, within the limits of I'm not going to use a microcontroller. Okay, so I'm going to have pin 2 is going to be called, I don't know, D0, and we'll just do it that way. And pin 3 is going to be D1, and pin 4 is going to be D2, and those will be my inputs from the other gal. And then our outputs are going to be all of these. I believe pin 19 is the second to last pin. I love how I still have FCUX open. Internet, that's what I'm going for. And where is my... Here it is. And yes, for the billionth time, pin 19 is that one. So we'll have... I mean, it's really pretty arbitrary, but let's start with pin 19. That'll be our output 0, and we'll just keep calling him Q. Why not? Who cares? Who absolutely cares? I'm only doing this because I don't have a chip that I need. And we need 8 of these. 1, 2, 3, 4, 8. And this is going to be 16, 15, 14, 13, 12. And Q0, Q1, Q2, Q3, Q4, Q5, Q6, and Q7. And now we just have to implement the logic behind each of those output signals, which is literally as easy as Q0 equals, it is only true if Q, I mean, it's just going to be like binary counting. So let's do them in this direction so they're kind of readable. So it's going to be Q2 and where is my and? This keyboard. Q1 and Q0. That is not I mean, that is not right because that would be the 8th pin. But what you do is you just slap a not on the front of the ones that you need to be 0, and now this will be 1 when they're all 0, which is how you I mean, pin 0 will be selected when they're all 0. Shocker. But then you literally just do binary counting with your values here. So let us renumber these. Q1, Q2, Q3, Q4, Q5, Q6, and Q7. And it's just going to be Q1 will be on when they're all off except for Q0. And then Q2 will be on there. This will be on when these are both on. This will be on when this is on and not the other two. This will be on when that one's on and that one's on. This one will be on when that one's on and that one's on. And this one will be on when they're all on. And there you go. Ta-da! Let me just double check that visually, but that should basically be a 3 to 8 decoder. Yeah, so 0, 1, 2, 3, 4, 5, 6, 7. Yeah. Save it. Build it. Oh, 8 errors. My God. Invalid oh, because I'm a dummy. These are D. Oh, Lord. God bless you, terrible editor and keyboard that I am only somewhat competent with. See? Somewhat competent. The backspace key on this keyboard is one, like, key unit big. It's not a big fat bar. It's really easy to mess up. Okay, now, compile. No errors. Beautiful. Let us stick in another. Yeah, let's go with that. Stick in another gal, because I have several of them for another project that I will now need to buy more gals for. Also, there is a cat just kicking shit around me. Eating plastic. Okay, and let us burn this. Let us burn this. Back. Load. Decoder. Boo-doo-doo. Program. Go for it. Wereworm says, man, I wish we had something like a complex PLD. Oh, I wish we had something like a complex PLD. Yeah, a CPLD. Yeah, a small CPLD would make life slightly easier, but we don't have it, so just deal with it. And Wereworm says, that'll show the 74 LS138 guys. Totally. I'm done, right? Yes. Back to here. Oh, what's the fastest way to test this up? I guess we should start by pulling it out of here, because I don't want to spend a lot of time futzing with this. And I guess I can just reuse my 8 LEDs from over here, which is going to be vaguely annoying, but whatever, because I would also like to use those when we're actually testing the NES. The cat is now on my bench, and he's about to mess up my day. I'm sorry, I love you, bud. I love you, but no! Always gets in the loveliest mood when I am doing stuff. So it goes. Alright, so for this guy, now that I've got that in, I should just be able to take these 3 inputs that I was feeding into LEDs moments ago, and I think this is my low bit, and put them into the inputs that I just specified as being inputs. And I guess I should probably put some voltage into it too, eh? Let's see, I believe VCC is this guy, and ground is therefore this guy. And I don't think I need to use output enable on this one, because if you aren't using any of the like registered features of the PLD, the programmer says, oh, you want this in like old school PLD mode, in which the clock input is just an input and the output enable is or if it's an output or an input. It is an input, so you can use it as input 9 if you're not in registered mode. They do that for compatibility with another old type of PLD. Right. And then I guess we just take these guys and move them over here, starting at this pin. Drilling. Then I'm going to have to move these back too, because I do want to use them to view what is being shifted, what is being latched out of and clocked out of the keyboard matrix, like when I'm actually controlling it with the NES. Because that will be the best way to debug. Come on, you can do it. You can make it. Reach! And of course, I'm sure my fat fingers are screwing up all of the other wiring here too, so cheers to that. One more. Cool, cool, cool. And that's that. Plug our Pi Pico back in. Have the cat yell in my ear from just off camera here. Okay, okay, all right. Stay up there. We have a light. That's cool. Is that right? I don't know. He says yes. And I think doodly doo, that would be, this is our highest, so this would be on if they are all on, if all three of those are, if all three of these guys are on. So, out of curiosity, what if I unplug the output enable on there? It does nothing. Huh. I would have assumed that would drop it to 0. Well, huh. Let me, actually, sanity check this by hand. Why am I doing it through the other chip first? So I will pull out these wires that are going to it. And it still has just that one lit up, which is probably because of the pull-up on the inputs. That would make sense. And yeah, this is already looking pretty reasonable. If I ground any of them, it moves the thing around. That's good. And let's see. Orange is the low bit, blue is the next bit, purple is the most significant bit. So that should take us to... Cool, that looks reasonable. This was our lowest line. So now if I just do some counting, they should just move to the right. There you go. There's 1, 2, nope. I mean, yes, but no. 3. Now 4. 5. 6. Wait. That was, what? Yeah, 5. Okay. Woo! 5, 6, and 7. Alright, so that works just fine. And now I don't remember which inputs are what on my counter, so that's good. They are, let's go back and look at the counter code. Where is it? Latch count. 19 was the lower. I seem to have had a theme. So let us plug those back in, send in some clocks, make sure they work properly together in harmony. I'm trusting you that you're actually all on. We'll find out shortly. Let's go back over to Funny, restart the thingy. Cool. make our clock pin again. So from machine import pin. Cool. Come on. Clock equals a new pin. That is on GPIO 0, and it is a output. And how is our latch input set right now? What are we controlling it via? What are we controlling it via? It is this purple wire. Latch is currently on, so that should mean we are clocking if we clock this. So let's do clock high, clock low. Hey, cool. That looks right. Chips! Goodbye, cat. Yes, we have made a Knight Rider situation. Go us. I mean, why not? Can I do while, blah, 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 blah. Let's just do while true. Actually, first we need to do from system import time. Nope. From, or is it just, it's just import time, damn it. Import time. Okay. While true, we're doing this just for the benefit of Wereworm. Clock high, clock low, and then what? Sleep, right? Time dot sleep ms. I don't know, 200 milliseconds. Can I do this all on one line like this? It sure seems to not really be doing anything. Did I Python wrong? Okay. Just make my pin again. Make sure I didn't do anything crazy. Yeah, that works. Cool. Import time. Time dot sleep ms 200. Right? Yes. Cool. So okay, whatever. We'll write it out with the indents and all. While true. Clock high. Clock low. Time dot sleep ms 200. There we go. There you go. There's your chase light. We've done it. Very good. And that's it. Project done. Okay, so we are actually pretty close to where we can slap this, hook it up to the keyboard. This is actually annoying because I would like to both see what matrix line I'm on and what the latched in value currently is. That's a pain. I wish I just had, I have no like just LED light bars, which is an annoyance. And I guess that is what it is. But for now, let's see. So I've already got my column or my row wires going into the latch, the parallel in serial out shift register, which is where they will be going. And then I have this counter, and that counter should be feeding its outputs to the column lines on here. So I guess let's just do that, because then we have, I mean, it's like, that's the hardware, right? Like, that's it. I think after that I just need to swap the clock and latch out for the NES clock and latch, and that's our hardware. My god. Okay, so back to the keyboard matrix, so I know what to plug in where. Oh, I still need the diodes though, don't I? Yeah. Blah. Oh, bleh. Okay, well... You know what I can do is just use the LEDs. Right? They're diodes. That should be fine. And I wanted them pointing out of the chip into the keyboard, right? Yeah, so why not? Just do that. I'm trying to think of a reason why not. I can't think of a reason why not, so we're gonna do it. And that should hopefully work. I don't know. That's what I'm gonna do. For starters, I feel like I have to scoot these chips down a little bit because I don't have room to do what I need to do here. So bear with, I'm just gonna move things. Thankfully, each of these pins has like a input. That's each one of these pins, each one of these chips has like a input. So not much to rewire there. Well, that's one chip. Oh, and I'm gonna have to move the LEDs down too. Damn you! Damn you, LEDs. And, oh, can I shift that one more spot down? No. Fine. That should still work. Whatever. Ground to ground. Oh, wait, I didn't move these down. Whoops. 1, 2, 3. And 5 volts. In. R. Count values in. And now, if I'm going to run everything through the LEDs as my diodes, you take the ground side, and instead of running it directly to ground, these will actually run into the keyboard. Fancy, right? So, let's see. I need to actually move these all down one spot as well, because otherwise they are going to overlap with one pin of that last IC there. They also go through a resistor. How much will that matter? Hopefully not. Hopefully that will not matter. Fingers crossed. How many of these? Should I do the right thing? Should I do the right thing? Eschew these LEDs? I think I have more than enough of these diodes. Let's see. Will they plug into my breadboard? Yes, because sometimes those leads can be too chonky on power parts. And I certainly have at least 8 of them, right? 1, 2, 3, 4, 5, 6, 7, 8. Fine. Because I don't want to mess with the things that resistor might the resistor in these LEDs might do to me, so. Fine. So actually, I'm just going to rip the LEDs out entirely for a minute here. And you know what? You know what I can do? I will put those on the back on the latch output. Because that'll be probably enough to debug, since we will know that well, like if we do a latch and we get the outputs we were expecting for the line that we assumed we were on, then we can presume the proper matrix line is selected. So that's probably fine, right? Oh, these are just borderline big enough to fit in here. Just barely. We're gonna make it work. Three. Four. The really fun part, if you think this is a thrill, you're gonna love when I have to solder this together. Man, that's just gonna be a riot. 5. Six. Come on. Come on. Seven. And last but not least, number 8. Get on in there. Get on in there. Do what I say. Okay. There's our diodes. I guess I'm going to start with the keyboard matrix pins. Let's just say this is going to be column 0, which is the one with the slash. And that is on pin 1, 2. Yeah, 1, 2. Oh god. 1, 2, 3, 4, 5. And this is pin 1, so 1, 2, 3, 4, 5. You are my man, Blue. Let's just thread this under here. Try not to break anything. Be unsuccessful at that. Be proud of ourselves anyway. You tried. Okay. Next is 4. That is this green guy right here. Nice. Next is pin 1. Next is the row starting in 0 is 2. The row starting in Z is 15, 14, 13, 12, 11. Which I believe is this one. 15, 14, 13, 12, 11, yes. Oh boy, do a little more weaving here. There we are. What was I on? That was the 0. The A row is on 3. 3 is hanging out here. It's this yellow one. The Q row is on 10. The one that was next to is a red one, which is this brown one. And the final row, the row starting with the 1, is pin 7, which surely, sanity check ourselves, should be the one I'm holding because it's the only one left. 1, 2, 3, 4, 5, 6. 6? Am I losing it? 1, 2, 3, 4, 5, 6. Oh, right, because there's the one that goes to the alpha lock. So there is another one hiding here. Oh, that's the one that I had already attached to something the other day because I was testing that particular matrix row. Very good. And then I guess that one that's for the alpha lock button, I'm just going to ground for now. And it will always be grounded and it will stay grounded from now into perpetuity. Okay, so that is my keyboard fully plugged into things. Now I just need to take those signals and attach them to the right stuff. So let's start. I need to, firstly, let's move some of these down out of the way. These are just power wires. All right, so connect the outputs of the decoder into the inputs of the diodes. I saw it disconnect, but I didn't stop because, you know, what are you really missing here? But just FYI, if you're keeping track at home, that we're on 5. 6. 7. 8. Okay, so that is our column select stuff going through diodes, going into the keyboard. So, I suppose it's probably a good idea to put those pull-ups that I was talking about on the column inputs over here, which actually should be like, wait, no, pull downs, right? Because I want these to start at ground and possibly be pulled up if to 5 volts if a key is pressed. So, just going to scooch these up so I have a little room. And then let me just use some of those resistors I used the other day for these LEDs. In fact, I have 3 that I can start using right here to pull these to ground. That is 1. That is 2. Is 3. More! I need more! Let's see, these were the 510 ohm guys. So these should pull up, these should pull things to ground pretty aggressively. Alright, what do I need? 3 more? Yeah. 1, 2, 3. Here am me, doing some projects and streaming it for free, kind of ad-based, ad-supported. Not that I am making any money, but theoretically. All right. 4. last but not least is Monsieur 6. I hope you really enjoyed watching me plug things into a thing. That was the alternative name for this whole project, is Plugging Things into Things, the series. Okay, those look like they're more or less not shorting out on each other. I believe you. And I guess let's go ahead and put this guy back. Put it on the output of the latchy-do. And for the purposes of testing, actually, I am also going to take the... It is this purple guy, is the am I in latch mode or not signal. And I'm going to put that on GPIO 2 of the Raspberry Pi just so that I can control it all over here from Python. There we go. Okay. Bear with me plugging in, well, only 6 more things. Or actually 7 things. Oh, that's one thing I have to hook up is the one of these, I guess the 0th matrix line also needs to be routed into... There should be 7 inputs here, shouldn't there? There should be. Because... Ah, wait, there are. Yes. Because I currently have the 7th one always wired to 5 volts. That 7th one is my detect that we are on row 0 signal. So that one I should just be able to wire directly to the signal from row 7. And also, let's put a pull down on that as well. You know, he's being very good for the most part. He's just kind of sitting here off camera, being like, yo, man, what are you up to? Yeah. Oh, no, poor boy. Okay, let's pull you down to the ground. And let's just bend that pin there. Perfect. Just as I planned it. These are such fine freaking legs on these things. And he's on my back. Did you hear him just instantly start purring? Now what am I supposed to do, buddy? Now what would you have me do? I'm sorry. You have to go. You have to go! Poor guy. let me just read the chat really quick because I saw it was doing some stuff, and I've been busy plugging things into things. Jacob David Cunningham, welcome to the chat. That's the first I'm seeing your name. He says, wires. Yes, very much so. Cliff said, just joined. Where is he needing diodes to improve N-key rollover? No, just to keep my signals from bleeding over and polluting the other basically feeding voltage back into, directly back to ground when a key is pressed on the same column, on the same row but a different column to the one that is actively being scanned. Wareham says the ghosting will be interesting. Oh, Wareham already said nah, just to save the outputs from shorting out. Yes, okay, you've got this. Cliff said back when I was doing the LED things, will there be enough current through the keyboard to have them light up? That's why I stopped doing that, because I don't know. Why don't they include a diode in every switch? Well, now they do, but for RGB purposes. Yeah. I don't know. Maybe they do, and I'm just dumb, which would be funny. Diode Ocho. The Ocho. Wareham said, big mess of wires. I love it, which I have said. BMAU is like a big influence. and supported with 8 viewers. That should be at least 0.0008 of a glass marble. And I'll let you know. And then lots of cat comments. Cat wants me to work on a mouse. That's fair. And Baser Tech says, hello from Istanbul. Fascinating how many, like, this is... The people who pop into chat are just from all over the place. And Trey Dempsey is here now he says he's out of work. Heck yeah, my dude. Let's relax and what should we should plug some things into things. Okay, let me put the chase lights back on the latch shift register doodad real quick like. Let me move this power wire. And like really the camera should be behind me and looking this way, because this is, let's just go to overhead for fun. Which is, you can see even less, but Lucas Wanderley says a keyboard with Pi Pico. The Pi Pico at this point is just for use as a test harness. It is eventually going to be driven by an NES, but this is the proving out the hardware before we get to plugging it into the NES and writing software just to make sure this part actually works in a sensible manner. Okay, working on grounds on these LEDs. Come on, Stubby. And I only need 7 of these. That's going to save me 1/8 of the work. Real savings there. Okie doke. And I started these from pin 19 on that one too, right? Right? Yes. We can just look at the source. Oh wait, wrong one. I can't mouse. PSIO. So my outputs were, yes, 19 is the lowest one. Following my, I don't know, schema. My standard schema. Good God, come on. Come on. People are watching. Work with me here. Just go in the damn hole. Ah. Nothing like stabbing yourself with a pair of tweezers. That's how you know they're good. Oh man, that was totally in the hole. This one's kind of bentity, so it is being a jerk. Yeah, these tinned twisted wires on these totally work great until they don't. I'm just going to say that's plugged in. It doesn't feel very good, but I need to move on. Oh, sorry, I forgot to count. 30. 4! We're getting halfway there. It's not even plugged in yet, but I'm already going to call that victory. There we go. There's 4. Nope, I plugged in the wrong one. Nice. 4. 5. Get in the right place, 5. Come on. Trying to get into spots you don't belong. We're a very oppressive breadboard here. Everyone must know their place. Six. Come on, come on, come on. You're probably in there, but I don't believe good enough. And 7. All right. Can you see that? Probably not, because I'm not on that camera. Can you see that? They're all lit up. Is that reasonable? I don't know. Let's go back to Thani and try doing some clocking and shit. Import pin. Make my clock pin. Also make my latch, which is pin 1, and that is also an output. And let's make sure clock is low, and let's make sure latch is low. Actually, let's first test, let's just latch, and everything should be low. Regardless of which of these matrix lines is selected, I have no keys pressed. So if I, actually let's bring latch high to put it into latching mode. And I bring clock high to clock the clock. That's a good sign, I think. But of course, I have no idea what matrix line I'm on right now. So let's go ahead and find out, I guess, by... let's choose a key. I'm going to go with the 1 key, because you can see it on screen. And I'm going to hold it down, and... I guess every time I latch and do a clock, it should count the matrix lines once and select the next one. And it should also latch whatever was basically in the previous columns, rows, into the latch. So let me hold down 1 and let me just make, I'm just going to write one line that's just... Actually, I should just be able to hold latch high and just clock the clock, and that should just work. It should move to the next latch and the next matrix line and latch whatever was on the previous selected matrix lines. I keep saying matrix lines. I said it all last video. Row, the previously selected rows, columns. You know what I mean. So let's just do clock high, clock low, and theoretically we should eventually see LED. Let's see, this is my least significant one right here. So how did I have this set up? 1 is on, I think that's the least significant column, the way I have things wired up. So I think that should light up eventually, if things are working properly. Or maybe it'll be that one. And that should come around again. Oh no, weird. Okay. Oh! Oh, yes! Yes! That came on because it was column 0. Right? Yes, actually, let's do this. Which one is... So the one with slash, I believe I have set up as column 0. So if I step through these again, I should get that on, and that will say that I am pressing down slash, and we currently have column 0 selected. Right? Yeah, like that. And then we are on... So that is the previous value of column 0, even though technically, hardware-wise, this will have column 1 selected right now. This will always be 1 behind. So we're at 0, 1, 2, 3, 4, 5, 6, 7, 0. How cool is that? That's some working shit right there. And then if we bring latch low, and we do the clock high, clock low thing, that will then clock out our values into the NES. Yay! And then when we read that, oh, right, because we're one chart, but when we read that bit into the NES, we know that it was on column 0. bruh, I think we're ready to plug this into an NES. Oh boy! Oh man! This is terrifying. Let me read some chat. Let me read some chat and steel myself before I move on. Baser Tech said, I just discovered you a few minutes ago. Yeah, that's what everybody says. And then they come in, they watch one stream, they go, huh, and then they peace out. So, good to see you. Thanks for joining in. No light bright for the monitors in the back. No. I don't know if I've said this on stream before, but, you know, this is an unfinished basement that I'm hoping to do something with someday. But, so as a result, there are like a couple outlets over there for like sump pump and whatnot. And then there is one outlet coming off the box that has its own circuit, but it's a GFCI. And I find that when I put too much stuff on there, even though that's not what a GFCI is supposed to do, and I should be under 15 amps because it doesn't blow the breaker, somehow that makes the GFCI blow. So I keep most of these off most of the time. In fact, most of them are probably unplugged right now. I would have them plugged in. At some point I will do the electrical in here, not shit. But Baser Tech said they made an NES emulator with an ESP32. Some problem with libraries, but still, that's a fun project. Putting emulators on embedded stuff has a weird soft spot in my heart. Yeah, Jacob David Cunningham was talking about retrobrighting those things. I just don't trust myself to do it, honestly. It's a combination of being too lazy to get around to retrobrighting any of them, being fine with them the way they are. Like, I collect them. It's partially to look at them, but it's to use them. Like, I have them to use them for fun. So, like, retrobrighting them isn't high on my list. And, yeah. So that's that. It's a combination of lazy and also I'm a little worried that I would fuck them up if I tried to do that. Okay, Trade MC just says, right, hotter than a June bride in a feather bed, which is a saying I have never heard before, but I am now in love with. So, okay, let me get over myself here and plug in this damn NES cable. So one thing is, I never actually wrote down which was which on here, because one of these LEDs is wired up to the latch pin and one of these LEDs is wired up to the clock pin, but I never, actually, don't worry about it. Wrote that down. So obviously this is ground. That's nice. Ooh, let's firstly, let us ceremoniously rip this Pi Pico off this board. We don't need you anymore. You are way too powerful for our needs. Oh, and now we just have to get, 32 freaking pins out of this breadboard. There we go. Get out of here. You're done. You're done. And that means, let's see, these are going to be my clock and latch, so I should not forget about those. These were my power inputs. Those can go away. And for the NES, let us see. I guess I need to turn on the Veal soldering iron. Wareworm says, retrobrighting is what everybody does. Take a new one and future yellow it. Yes. I do kind of like old school sleepers. I don't love them, but I don't hate them either. I will let them stand. I think the only thing is me being the kind of unbearable computer nerd that I am. Oh boy, I have to be over here to get out of the way of this window. It just makes me sad. I'm sure, they're probably taking broke-ass computers and doing that, but if they're taking a perfectly fine working computer and making it into a sleeper by ripping the guts out, that makes me a little bit sad. I mean, it doesn't make me incredibly sad. I'm not going to go protest them over it, but it's just enough to make me... I don't know. I still like it. So that's not saying much. How should I deal with this? Maybe I will just solder one of these guys directly onto here, and yeah. That seems fine. How long have I been streaming? An hour. So we will see about getting the NES over here. I might get this hooked up, double check my connections, and then... Because the fun thing is, you can't test this in the emulator. I mean, I can test that it doesn't break anything, but I cannot, this keyboard does not exist. Unless I were to do a little work on the emulator, which I don't care to right now. Also, I just don't have the time. The FCEUX has no idea about this keyboard existing. So, yeah. Alright, let's jam that into ground. And let's figure out which one is 5 volts. Doody-doo. Bee-ba-ba. What's the easiest way to do that? Should I just flippin' plug it in? I mean, why not, right? No, be better than that. I probably won't drag the NES over here today. It's just too much. Just too much. So let us pull up an NES controller pinout, which hopefully I still have one up, you would think. Video stuff. Video stuff. Video stuff. Video stuff. Video stuff. Nice. Okay, I guess let's just search for controller. NES controller. I know there's a pinout in here somewhere. Controller port pinout. There you are. And 5 volts is on. Oh my god, this cable is so long. Where is your other end? My god. Right here in front of me. So it is the angly boy. Right there. Right there. Do you see it? So I guess let's put a wire in there. And I guess connect the other end of this to like my multimeter or whatever. Which you will never ever be able to see. Okay. Jam wire into the thing. This is a technique that's worked for me since I was about 8 years old. Okay, I have tried all of the wires available to me, and they don't do anything. Really? 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 I thought I had one of these plugged into... No, I had one plugged into 5 volts just to prove, just as like a sign of life. That's right. So white is 5 volts. That is correct. That makes sense to me. Get out of here, LED. You are no longer needed. And let's use a white thingy for a white thingy. I have this. It looks way bigger on camera. It's like the size of a hand to work in. Yeah, analog, Jacob, analog multimeter. I mean, I don't have a good multimeter. I should buy one someday. You will find this is like the meme of my channel, and of me as a person, is not even because like I don't have the money. I just don't have good tools, and I don't use good tools except for this beautiful Hakko soldering iron that my wife bought for me. because she is sweet. But yeah, toenail clippers. I don't have a proper pair of wire strippers, so I use toenail clippers. I have this multimeter that I literally bought at the Ace down the street because I needed one for something, and I have a little Radio Shack digital multimeter that works fine for most uses. I mean, I'm just doing digital crap, so it's like, is it connected or not connected is the most I do with it. So it's fine. But yeah, the battery's actually dead in the Radio Shack guy right now. So we are using the analog multimeter. And I don't want to hear another word about it. All right. Theoretically, that is some power. And then I just have to do latch and clock and Comcast will have a piece of my mind when I'm done here. Trade MC says virtual NES also seems to have keyboard support. Yeah, but this does not work the way there is an NES keyboard. This doesn't work quite. It works similarly. It doesn't work the same way. So not worth futzing with. We're just gonna, like, the code for doing this should be easy enough that it shouldn't take many tries to get it basically working. Anyway, the orange wire is something. I need to look up if it is clock or latch. Are you clock or are you latch? Are you human or are you denser? Which one is... Okay, clock is the one opposite 5 volts. Is it you? I don't think so. I think this one is latch. Yeah, probs, because it's not doing anything on the multimeter. And it's called... Oh, and it's called D0 on here. Yeah, weird. But that is non-chamfered side all the way to the bottom. No? Really? What the hell? Apparently that's the yellow wire. Okay. D4. What is D4? Is that connected to anything? No. I don't know what these things are. I don't know why they're calling them D3 and D4. Let's just not ask too many questions. Yeah, like this one is not connected to anything. You can't see what I'm doing. Doesn't matter anyway, because you wouldn't be able to anyway. So what on frickin' earth was this connected to? Unless I'm just not getting good content tonight. No. What? Oh, and we're going to need to wire up out, too. That's one that we were not doing anything with yet. Okay, so non-chamfer side, second from the bottom is out. Oh, that's that, duh. Okay, that's out from the... Out is the latch line. Yeah, duh. Out is... Okay, yeah, so this was latch. So my orange wire is latch. Hoopy doopy doop. Right, those D ones are... Those are the connections for data coming from the controller back to the NES. So I will just plug that in where the Raspberry Pi was. And finally, we need clock, which it says... Actually, no, that's not finally, because I need to do the data out. Damn you. So one of these is one of them, presumably. I have a... You know what? I'm just going to get rid of this for a second. Away with you. Wrong screen. Away with you. There we go. Yes. I have a red. I have a white. One of them is clock. Only one can survive. Yes? Yes. Clock is the red one. Yay. Now you know. Whack some solder on one of these guys. Where did my solder go? Right here. Attach it to the fucking wire. Get it done. Doodly-doo. All right, jam that into clock where the Raspberry Pi was. And finally, I mean, I should check this, but that means that this one should be D0. Let's find out together. D0. Yay, theory confirmed. Let's find a yellow wire to keep things pretty. And D0 will connect to, doesn't really matter, can be the highest order or the lowest order bit of this guy. And because of the shifting action, that will get all of the relevant values coming out of the keyboard in turn as we hit the clock signal. And I guess I have to choose. Oh wait, no, it does matter because it matters the direction that we shift. Which way do we shift? We shifted this way, right? We were shifting this way? This way? We were going this way? Or were we going this way? I pulled out the Raspberry Pi. Uh-oh! Well, I think that was right. I think we shifted towards, this is the one that's unplugged. And I think we shifted towards that one. So I'm going to believe in myself. And that's that. That's a thing. Should I, like I'm already at an hour 18, I should control myself. So let's just, I guess, get the NES over here, plug it in, turn power on, and just like make sure we get power. Then I might read some chats, but yeah, clearly, like I shan't get into software today, but we will get into that tomorrow. BRB. Okay, here's an NES. Do you believe me? It's really right here. Now let me set it down right on top of the hot soldering iron. And yeah. Sure. Like, I'd love to have it here in a way that you can see it, but it's not really in the cards. Unless, well, now I can shift everything over because I got rid of that window, so maybe let's do that then. Just move the mess from one area of the desk to a slightly different area of the desk. Yeah, there we go. There we go. Now you can watch me plug it in. Which is very important that you see with your own eyes. Let's put this in a controller port that doesn't matter which is which. Sure. And be here. There. Fine. Trade MC says shifty business. Sorry, I have not been keeping up with chat. There's too much to do here. Okay. Let me just. Oh, wow. The power brick is actually like working the right way. There you go. We have power. Check that out. Whoa. Yeah. That's it. There you go. We're getting power from the NES though. Check that out. That's cool. I chose the right thing. Okay. That's our thing for today. Didn't get to software. That's fine. It's only Tuesday. It's only Tuesday. Maybe we can bang out the whole, like, keyboard reading should be pretty easy if everything works right. So writing that routine should be I feel fairly confident I can do it all tomorrow, and if not all tomorrow, then the next day, which would be good because, boy, I'm on a tight deadline, and I want to wrap this part up quick. So let's read some comments because, man, I got a lot of people in today, relatively. And a lot of them are, Santiago says, and another drop. Yup, welcome to my internet. Sorry. Whereworm says, you should stuff a Raspberry Pi Pico into the multimeter just to say beep on continuity. You know what would be pretty good? If I use this multimeter for nothing else, just like put a contact at the far end of the travel, and then literally just hook it up to like a piezo with a piezo and a 555 or something. Just go boop. I would love that. That's a great idea if I weren't already doing this stupid project. Jacob says, sacrifice breadboard wire. Yeah, yep. This stuff is so cheap on Amazon, actually. I feel bad buying stuff from Amazon. I still do. I feel guilty. I don't know. It's just wrong. There seems something just wrong about it, but we're all doing it. And the world is fucked. So what are you going to do? But, like bits and pieces, those wires for connecting things together, that's the word I'm going to use. Super cheap and easy on Amazon. They show up the next day. It's so good. So I don't even care. They're great. And Wereworm said, it should not beep, but say the word beep in a deep voice. Okay, then you need the Raspberry Pi Pico. Cliff Cheney said, yes, shifts towards me. Good. I was pretty sure. Thank you. Trey Dempsey says, that's what I do for continuity. Say beep. I do. Let's make that a meme on this channel, because for people who were not watching some of the older ones, Trey, Dirt Piper, and Wereworm are kind of my always in chat people. And one of them, I think it was Wereworm, told me to just say beep because I just use resistance mode on my multimeter because I don't own a multimeter that has a continuity checker. Oh, yeah. Trade MC says, shifty business. Jacob David Cunningham says, what is the keyboard from? Yes, I get asked this every stream. It is from a TI-99 4A that I ripped apart, and it's sad, and I don't want to think about it. But the keyboard survives. Trade MC says, keyboard reading will just be like a multi-tap controller per column. Yeah, totally, is basically the idea. The software is going to be slightly... Well, I legitimately guess about how a multi-tap works, so if you're telling me that's how a multi-tap works, that just tells me I got it right, because that's what I assumed. But yeah, the way this is configured, every time... It's all synchronous because they're gals, so there's only one clock input. So when I bring the latch high and do a clock, that simultaneously moves to the next matrix line and clocks in whatever was on the current column. And then if you lower latch, subsequent clocks will not cause the matrix line to change and will do a shift. So it remains to be seen, because on the NES, every time you do, you can't just like turn the clock line on and off. It's just you read from a register and it clocks the clock line and gives you what the value on the data pin was. So hopefully that part will work right. And on that, I mean, I guess it doesn't matter either way. If I don't get the value on that first clock, I can just... No, I have to get it on that first clock. If I don't get it on that first clock, then the second clock would give me the second bit, so that would be bad. And I would just lose the first bit, which is not good. Which we could adjust the hardware to account for, so that's not a big deal. I don't think that will be the case. I think we'll be okay. But yeah, that's basically the idea. Like a multi-tap, each column is 6 bits, actually 7 bits of key information for one column. A 7th bit for detecting that we are at column 0, so that I can kind of reset the keyboard by scanning through when it first starts up until we get to column 0. What Dirt Piper says, I need to buy more cloth insulated wire, which will doubtlessly be an eBay purchase. The electronic projects I work on aren't authentic without flammability. That's fair. I mean, what kind of cloth even is cloth wrapped wire made out of? Like, the old stuff is like literally just straight up cotton fiber, if I understand correctly. But like, I have to assume the modern stuff is less flammable, right? That there is modern stuff that's less flammable? I don't know what you're getting into, Dirt Piper. Don't burn your house down. Don't, please. Dirt Piper says, it's a rubberized cloth, always has been. That makes sense. You know, manufacturing stuff is always fascinating. I love banal manufacturing, like, how's it made stuff. And one thing that, like, I always just wished there was more content on, like, if somebody can recommend me a good video that's like a how it's made style thing on the manufacture of like multi-wire cabling, you know what I'm talking about. There's a word, there's better words for that, but you know, stuff like this that has multiple insulated wires running through it. I would love to see like the machine that applies the insulation to the wires as it's going through it, and that just seems like a cool process. I would love to watch and learn more about that. Trey Dempsey says, you have 2 extra pins, I think. If you're talking about, I may have been talking over this while you already said that, but yeah, I have 2 extra, kind of, because there are 6 rows. There are 7 on this keyboard matrix. There are 7 columns and 6 rows, and my rows are what's going into the latch. So it's a 8-bit wide latch, or it would be. It's actually, I made it. It's actually a 7-bit wide latch, and it's 7 because the 7th bit is my detecting that we're on row 0 bit, which is 0 for everything except for row 1, always. And Jacob David Cunningham says, like USB-C, and yes, very much like USB-C, because I don't know if you have ever... 2 extra pins on the controller port. Yeah, I don't know what you... they're listed on here. It's off screen now, but on that pinout, there's D0, D3, and D4. So theoretically, I have extra inputs. Can I read them? The documentation seems inconsistent on that. Like, they're listed on there. They're definitely not connected on this cable. So it doesn't really matter for this, but are they usable? Trey Dempsey says, yes, you can. Yeah, do they just show up in that same register when you get the... I don't know what I'd use them for, but that's good to know. But yeah, sorry, to roll back, like USB-C, yes, I'm sure probably anybody in this chat, I mean, you know, I don't want to exclude anybody, but there's probably a lot of people here who are aware of Tube Time. Eric? Is that his first name? I was vaguely aware of him, but he came to prominence recently. He's been doing a lot of stuff with Curious Mark, which everybody knows. And he and some guy that I don't know apparently did a book on like cross sections of electronic components. That sounds pretty cool, and I've seen some pictures. And they did a cross section of USB-C, and it's insane, like the amount of stuff that is in there. I mean, obviously you have all of your twisted pairs for... Well, apparently it's not even twisted pairs at this point. There are like coax. There are like multiple coaxial things inside of there, plus your wires just for USB 2 support. It's wild. And manufacturing of that seems relatively straightforward. Is basically you just, make your things and then you bundle them to get, I assume there's like a machine with molten rubber that applies it to the outside of the wire as it's traveling through, and that's how you get your coated wire in the first place. And then, you kind of braid them together, and then there's the next level of insulation, which I assume is put on in a similar process by a similar machine, but I've never seen it done. And I used to work in automotive R&D, not actually doing automotive stuff, but you just learn a lot of really interesting manufacturing stuff working in that kind of environment. And It leaves so much to the imagination of how you don't know how all the shit around you is made, because it is made by really interesting machines. Yeah, Trey Dempsey says the wire is coated by passing through a die. Like, I intuitively know this. I just want to see it done. Dirt Piper says, how long until we get UPB, Universal Parallel Bus? And on that nonsense, I will finally knock off for the day, because it is over an hour and a half now. An hour and 31 minutes. So, looking dead into the camera. See you guys. Next time, we'll make some software. We'll make this happen. We'll read a keyboard. But until then,